Hello, I promised my students I was going to give them a lab report preparation video. And this is it, guys. We are showing you the 3 steps we want you to use in the lab report preparation, as well as the project preparation for your presentation. These are the essential elements. The first thing is the introduction. This introduction should, in the case of lab experiments, explain in your own words what you think the purpose of the lab is. Ask yourself the question, why are we doing this lab? How does it relate to the course? What do you think is the reason why you are doing this lab? And what do you hope to gain from it? If you're doing a project, well, obviously you are going to introduce your project by describing what it is and what it does, and why you have chosen this project for the course. What is the relevance of your project to the course? Everything has an introduction, and that should suffice to get you started. Now, if you're doing a lab report for labs that have been given you, then the next step is to treat the lab experiment as if it is another assignment question, or even maybe a class test question. That is, basically you have to take a function, you have to simplify it with a Carnot map, you have to put it on a truth table, you have to find a logic diagram for it, and that is basically that for the combinational circuits. Or if you have a finite state device, sequential circuits, you need to have the state equations, the state table, the state diagram, the input functions, any simplification Carnot maps you might have. Basically, treat it as if it's a theory question. All you do for the labs, because they're online labs, is take the logic diagram after you have worked out what it is and build it in Multisim. It will have already been tested and shown to me, so all you need to do for that part of it is to include the Multisim circuit as a graphic. Use some sort of screen capture on your computer to record the circuit within Multisim and include that with your lab, along with all the theoretical part. The last part, number 3, is the conclusion. The conclusion just mentions any issues you had with your circuit. And some students have had issues. They initially built their circuits wrong. They may have had problems. Their circuit didn't work the first time. They had to change a few things within their Multisim. You know this, and I know this. I've come around to test your circuits, and I've not found that they are correct, and I've given you some instructions, and then you go ahead and do it. All that should have been documented. But basically, in your conclusion, you will tell us what happened when you tried to build your circuit in Multisim. And if it worked correctly, according to the truth table, or according to the state diagram, or according to the state table, or whatever else it is that you did, you will indicate this. And if it did not work correctly for whatever reason, you will try to explain why it didn't work correctly. And because Multisim is not like labs, you should ultimately get it to work correctly, and then you may say that the circuit worked correctly as your conclusion. In other words, it confirmed whatever it is it was supposed to do. Now the last business has to do with the questions that are actually asked on some of those labs. I have written questions in the lab, and of course you will provide the answers to those questions in your conclusion. So basically, introduction, theory and tables and whatever it is you want, and then conclusion. That's it for the lab people. For the project people, obviously after the introduction comes the diagrams that demonstrate the physical aspects of your project, photographs of the project, credits to whoever helped you with the project physically, and then the code. If the code is original, indicate that. Commented code is desired. You have to tell us what the code does. Don't simply give us a piece of code with no comments. You have to bring me and anybody else reading your report to explain what your code does so that we can follow your code. If you have subroutines in there that were standard libraries or standard code that you got off the internet, do not remove the credits in the comments. Leave it there. We know that the PID library was built by so-and-so, and you can proudly reference the fact that you used it and it worked. Okay, so it's important that we know and that you be honest with your project relating to any originality and any used material that you found on the internet. And then of course you also will have some sort of conclusion to your presentation and your lab report material, which actually is the presentation materials, usually some sort of PowerPoint or PDF presentation, and any additional video clips that you might have of your project during the creation stages or during it while it's working. You will include that in the final package that you send me for evaluation. The conclusion for you people who are doing the project will usually be, in addition to mentioning any difficulties that you had along the way, we hope that you will be able to say your project worked satisfactorily as designed. If that is not the case, or your project didn't work at all, then you need to comment here in your conclusion as to what were the reasons that you were not able to get your project to work as you see it, and give some more insight as to what went wrong. So that's it. Nice and sweet. Guys, I've shortened it down to 3 logical sections: introduction, body of the material, and conclusion.